Hi everybody, and welcome back to lesson 39 of the Dead Earth game development series brought to you by the Game Institute. This is lesson 39, Zombie Player Awareness is what I've decided to call this lesson, really for lack of a better title. You see, what we're going to focus on in this lesson is making the zombie more aware of where the player is. Now, our zombie is already quite aware of where the player is. For example, we know that if we shine a flashlight on our zombie, even if it's got its back turned to us, it will recognize that because of that flashlight collider, and it will start seeking to try and find us. And we also know that if the zombie sees us, then it's going to come and start trying to attack us. But what we're going to work on in this lesson is giving our player an audio footprint as well, so that if we run instead of walk, the zombie will hear us. Or if we were to jump off a ledge and land on a floor, then we would want the zombies in the local vicinity to also hear that and react to it and investigate the sound source. Before I get into that though, I need to address some issues that I actually introduced in the last lesson when I added the lower body and upper body layers to our animator. I actually made a glaring oversight and in a way kind of broke our system slightly. Now, for those of you that haven't seen the problem yet, let me show you here. So I'm going to select Jill's AI entity game object, and I'm just going to make sure that she has no lower body damage and no upper body damage, okay? So the layer weights for the lower body and the upper body will be set to 0 when we press play. So we know that their animations will not visually alter how Zombie Jill behaves. But you'll notice that the animations on the base layer, which all worked fine, don't seem to be working quite right now, and I'll show you what I mean. If I go up to Zombie Jill, put my flashlight on, she's now going to seek around to find me, and she's going to run into this wall. What's going on? As you can see, she totally overshot the mark and failed to track me. The thing that I completely forgot in the last lesson, when a layer has its weight set down to 0, although it no longer influences the bones in any way visually, any scripts on these states, such as our root motion configurators, still get executed. Now, why this is a problem is because although we originally copy and pasted this locomotion setup here from the base layer, what we did do was go in and change the transition time. On the base layer, the transition from idle to turn left and idle to turn right and back again was 1/4 of a second, but we've set it to 1.25. So what's actually happening here is the following. Although this layer, which is the upper body layer, is turned off with respect to its layer weight, its scripts are still animating. Therefore, on the base layer, which is the one that we can actually see, we come out of zombie turn left in 1/4 of a second into idle, and then we go into a zombie walk or a zombie jog when the player sees us and starts running towards us. However, as we come back into zombie idle and back into one of our walk, jog or sprint animation states, on the lower body layer, we are still in this transition from zombie turn left to zombie idle. Okay, because remember, it's a longer transition. So in other words, the base layer has got from idle and into the walk, jog or sprint states quicker. However, the root motion configurators are still being executed, and we can see that when we're in either zombie idle or zombie turn left, we are telling it we are using root rotation, which basically means our base layer, which are the states that are being executed, we're walking and we're running forward, but the reference count, which should be 0 of our root rotation, is actually 1 because the layer above it is also assigning a root rotation of 1 to that reference count. And that doesn't really correct itself until the lower body layer also gets itself into the walk, jog or sprint states, which don't request root rotation. In a nutshell, what happens is on the base layer, we're telling our zombie to run towards the player. And at this point, normally, because we haven't requested root rotation, the pursuit or attack state would be rotating our zombie on the spot. However, on the lower body layer, we may still be in the idle state because of that longer transition time where we are requesting root rotation, and therefore our actual code is being told not to rotate it on the spot because we do have a non-zero root rotation request, which of course only resolves itself once we get into these states. Now, there's several ways that we could resolve this, but the best way really is just to make sure that any layers that are supposed to be kind of replicas of the base layer functionality also share the same transition time. So you'll see if I put the transitions on the upper body layer from idle to the seeking animations back to 0.25, both for the left seek and the right seek, both from idle and to idle, this will completely resolve the problem and our zombie will no longer look stupid and start running into walls. So let's have a look, see if that resolves the problem. Yeah, you can see it came straight at us then. So those are one of the things that you really have to watch. A real gotcha there is just because a layer may be turned off by having its weight put down to 0, any scripts on those states are still being executed. And in our case, we know that that's telling our AI state class that root rotation is being requested, and therefore we're really altering how the locomotion is being carried out in our code, because we're no longer rotating it on the spot immediately when we enter walk, jog, or sprint. The other thing that I overlooked is that the lower body has the idle as its default state. And the same thing is true, okay? Once we're in crawling mode, we know that the lower body layer weight will be set down to 0, and therefore all of this crawling logic will happen on the base layer. However, when we're crawling, root rotation should be 0 again, but in our lower body layer, when we're crawling, we're just going to be back in this idle state, which is requesting root rotation. What we end up with is visually the crawling animations being played out that we've set up on the base layer, but we're not having our zombie being rotated on the spot as it should when it's crawling, because on the lower body layer, we have this idle state or any of the other states requesting root rotation, cancelling out that functionality. So what we really need to do is make sure that when we're in a crawling state in our lower body, and technically probably our upper body as well, although I don't think that has a root motion configurator on it, so it doesn't matter, but definitely on our lower body layer, we need to make sure that whenever we are crawling, we always go to some empty state, doesn't have any root motion configuration requests on it. So in my upper body layer, in some blank space, I am going to create a new empty state, and I'm just going to call this empty, and I'm not going to assign it any motion field, okay? And then I'm going to create a connection from the AnyState to that new state, and I'm going to set the transition from any state into that new state. I thought I called that empty. I always do that. I forget to press return, so I'm going to rename it again, press empty, there you go. Okay, so going back to my transition, I'm going to make sure that the transition is simply that when crawling is true. And what I'm also going to do, just so that we're not always going from any state into empty state many times a second, is I'll just say that we cannot transition to self, okay? So once we're in this empty state, we can never leave it. And that's perfectly okay, because for us, we know that when our zombie is in a crawling state, it will never not be in a crawling state again. A zombie is only crawling when its legs are totally damaged, and there's no way for its legs to become undamaged. But if you wanted to, you could of course create a transition from empty back into idle, like so. And you could say that you want this to be triggered whenever crawling equals false. It's never going to be executed though. In fact, the only place where it might be executed is if you were tweaking with the zombie state machine's inspector variables and you were changing its lower body damage at runtime. But we're not going to be doing that, so I'm actually going to delete that state by selecting it and pressing the delete key, and I think that should solve that problem. Like I said, we don't need to do this on the upper body layer, because on the upper body layer we're not actually changing any of the root position or root rotation reference counts at all. So this will simply have no effect when it's set down to 0. And it will always be set down to 0 when our zombie is in a crawling state, allowing that default crawling behavior to show through. Oh, actually, what I should probably also do is that transition on our lower body layer from any state to empty state, I should make sure has exit time isn't ticked, which it isn't. And I should probably set the transition time to basically 0 so it happens instantly. Okay, so that's the old problems fixed, hopefully. Now let's get on with the stuff we want to cover in this lesson, the new stuff. So the first new thing we're going to add to our game in this lesson is going to be the ability for our player to make a noise that the zombie can hear and react to. That noise might be the sound of the player running on the floor, or perhaps the sound of the player's feet landing on the ground after a large jump or fall. Of course, our AI system already has audio awareness built into it. From a zombie's perspective, an audio source isn't something that it can actually hear. It's not something that makes a noise. The noise is just a sound clip that we play so that the person playing the game, the human being, can identify the sound source. From a zombie's perspective, the sound source is simply a trigger that is on the AI audio aggravator layer and tagged with the AI sound emitter tag. Therefore, all we have to do is create one of these triggers as a child somewhere in our FPS controller rig hierarchy. Let's say we create a child game object of our FPS controller rig and add a sphere collider to it, configured as a trigger, assigned to the audio aggravator layer and tagged with the AI sound emitter tag. Then, in response to different events happening within the game, such as the player running or the player landing on the ground after a fall, we can simply enlarge the radius of that sphere trigger. And of course, any zombies that are within the vicinity will then register that as an audio aggravator and will seek to the position of the sound source. So let's do that now. I'm going to call up the scene view. I'm going to select my FPS controller rig, and with my FPS controller rig selected, I'm going to right click and I'm going to choose Create Empty to create an empty child game object. I'm going to rename this game object Sound Emitter. With this new Sound Emitter game object selected, I'm going to, from the Layers drop-down in the inspector, assign it the Audio Aggravator layer and assign it the AI Sound Emitter tag. I'm then going to add a Sphere Collider component configured as a trigger. In other words, making sure that the isTrigger property is ticked. We have now added an AI aggravator to our FPS controller rig. If I select the entire rig, we can see that this sphere at the moment is pretty small, but it's in the center of the object, so we could move it down to the feet, but I don't think I'm going to. I'm just going to leave it centered at our FPS controller rig's position. So, in normal situation where we're walking, we might say that the radius is 0, perhaps we even turn off the sphere collider. But then when running, we might decide to grow this significantly so that if we run past any zombies and any zombies enter the radius of our running sphere radius, then those zombies will react to that as any other audio aggravator and will turn around to see what made the noise. Furthermore, if we fall off of a ledge and land on the ground, we might decide to set that radius even bigger for a couple of seconds or so that we make a louder noise. And of course, in the actual game itself, all of these actions will also be tied in with sound effects that we play so that it also gives the player playing the game those audio cues as well so that he knows he's making a louder noise. And that's what makes the whole thing so terrifying. So for now, I'm going to set the radius down to 1. And what we're going to do is we're going to write a new script for this sound emitter that's going to have functions that other objects can call to talk to this sound emitter and to change its radius. Now you might be thinking, well, why do we need a script to change the radius of this trigger? The reason being is it's going to be slightly more complicated than that. You see, let's just say, for example, our player jumps off of a ledge and lands on the ground. Now, at the point when that interaction with the ground happens, we might have our character manager contact that sphere collider and tell it to go to, say, a 10-meter radius. However, in the character manager's update function, each frame it's also going to be determining whether we are running or whether we are walking and setting the radius back to that smaller radius. Therefore, if we jump and land on the ground, that radius is only really going to be set for one fixed update, and we could have timing issues depending on how the scripts are ordered in their execution order. Let's say, for example, we have a load of zombies nearby, we jump off a ledge, we land on the ground, then we, for a single fixed update, set the radius to, let's say, 10 meters, but then the very next fixed update, that radius gets reset to just the standard walking or running radius. Well, then it might be that interaction with that larger trigger is missed by the zombies. So what we're going to do is whenever we wish to set the radius of the trigger, if the radius that we wish to set is larger than the current radius, then we're going to instantly snap it to that radius. So let's say, for example, we're walking, we walk off a ledge, and then we make a big landing sound on the ground, and then we want that radius to be 10 meters, well then that set function will immediately snap the size of that radius to 10 meters. However, in the very next fixed update, we're just going to be walking again, and we don't want that radius to be snapped instantly down to the walking radius that might be 0 or very small. So in that particular case, the size of the radius will interpolate over time down to the lesser target radius. And that way we just make sure that if anything makes a sound, it doesn't just make a sound for a single split second, a single fixed update. And just gives us a little bit of protection to make sure that such things aren't missed by the physics system. So let's create that script now. Well, I'm going to create this in my scripts folder, in my AI folder. I'm going to right click, I'm going to choose to create a new C# script, and I'm going to call this AI sound emitter. I'm then going to drag the AI sound emitter script onto the sound emitter game object that is a child of our FPS controller rig. Of course, it's just an empty script, it doesn't do anything yet, so let's open it up in MonoDevelop and give it some inspector properties that we can play with, and also implement some functions that's going to perform that radius interpolation. Okay, so here we are just looking at the boilerplate stuff in our new AI sound emitter script, and I'm going to delete the update function. We're not going to need that function. We will actually be creating a fixed update function later, and it's in the fixed update function that we are going to animate the radius of the sphere collider, because a collider is obviously a physics-based object, and therefore any changes that we do to a collider, or in our case a trigger, should be done in the fixed update, not the regular update. So let me create a comment saying inspector variables, and the only inspector assigned variable I'm going to need is a decay rate, which is going to describe in seconds the amount of time it's going to take the interpolation from our current sphere radius to a smaller sphere radius. Remember, whenever we set a new radius for the sound emitter that is larger than the current radius, then we're going to instantly snap to that new larger radius setting. But when we set one that's smaller, we're going to interpolate over time. So I'm going to call this variable decay rate. It's going to be private, but I'm going to serialize it so it shows up in the inspector. So I'll say serialized field private, can be a float, as it's basically seconds, and we will call this decay rate, and by default I will set it to 1 second. Then we're going to need some internal variables that we're going to use for tracking the animation, keeping track of what the current radius is and the radius that we're heading towards. And we're also going to need to maintain a reference to the sphere collider that's on this object. Another important point is that this AI sound emitter script should always be added to the same game object as the sphere collider that's going to act as the trigger. So I'm going to create a new sphere collider object, and I'll just call that collider. I'll set it to null by default, and then we will hook that up in the start function. I'm going to create two floats now that will be temporarily used to store the two radius values that we interpolate between. So let's say, for example, our current radius is 15 and we want to set it to 2. The minute we do that function call to set it to 2, we'll kind of have the source radius be set to the 15, the current radius, and 2 be set to the target radius, and then those are the two values we will interpolate between over time. So I'm going to call the first float source radius. I'll set all these to 0 by default, and I'll call the second one target radius. Also set that to 0 as well. And we're also going to need to keep track of an interpolation value between 0 and 1, so that's going to be another private float, which I'll just call interpolator, like so. And finally, another float that's going to keep track of the interpolation speed. Interpolation speed is simply going to be 1 over decay rate, and we'll hook that up in the start function as well. So I'll call this last float interpolate speed, and I'll set that to 0 by default as well. Okay, so the first thing we'll do then is we will hook up our collider reference. So we will say collider equals get component sphere collider, like so. And if we've been unable to get a collider, then it means this script is just useless, so we might as well just return and not bother doing anything else. We'll also bail from the fixed update function if we haven't got a collider as well. And I'll put a comment above there saying cache collider reference. Next up, when we start, we'll just set the source radius and the target radius to the same value, which is the current radius of the sphere collider at startup. So I'll put a comment in there saying set radius values, and I'll say source radius equals target radius equals collider.radius. Next up, we'll set the interpolators to their default values. So we'll set our interpolator, which remember is going to be a float that is just simply used to count between 0 and 1 using time.delta time, or actually, because this is going to happen in the fixed update, we're actually going to be using fixed delta time. But you get the idea. It's tracking the number of seconds that have passed. So we always want this to start off at 0. And next up, we need to calculate the interpolator speed, which is 1 over decay rate. But we better just make sure that decay rate isn't less than a very small value. We don't want to get like a divide by 0 or anything. I think probably the smallest decay rate we should support is 0.02 50th of a second, which in our game is going to be a single physics time step. If it is less than 0.02, then we'll basically just set it to 0 and we won't do any of the interpolation. But you'll see how that's going to play out in a moment. So I was say if decay rate is larger than 0.02, well then interpolator speed equals 1.0 over decay rate. Else interpolator speed equals 0. Okay, so I think we've got everything we need now to initialize this class. What we need to do now is probably create the fixed update function, another one of Unity's magic functions, which is called automatically by the Unity engine. And what we're going to do in this function is we are going to each update increase our interpolator value by time.delta time multiplied by interpolator speed. Okay, so in the case where interpolator speed is 0, well then it doesn't really matter, nothing's going to be changing and we're not going to be interpolating at all. But in the case where, let's say for example, we have a decay rate of 2, that will create an interpolation speed of 0.5. And then when we add time.delta time times 0.5, well, that's basically means that in order for our interpolator to go from 0 to 1, it's not going to take 1 second, it's going to take 2 seconds. Okay, so in our function, we will say that interpolator equals, and then we're going to do a mathf clamp 0, 1. We never want our interpolator to be outside the 0 to 1 range. And we will pass in the current value of our interpolator plus time.delta time, which remember, because we're in the fixed update, we'll actually evaluate to time.fixed delta time, which is the time of our physics step, which should always be 0.02 because we're running at 50 frames per second, multiplied by our interpolator speed. So now we have our interpolator, we need to use that to interpolate between our source radius and our target radius to get the current radius. So we will say collider.radius, which has just reminded me actually we should put at the top of this function, if we don't have a collider reference, and just return, let's not do anything. Otherwise I'll say collider radius equals mathf.lerp, and we're going to lerp between the source radius, the target radius, using our interpolator. And then I think what I'll do is I will say if the radius of our collider is really small, then turn the collider off so it's not being processed at all. So I'll say if collider.radius is smaller than mathf.epsilon, basically if it's close to 0, then we will say collider.enabled equals false, else collider.enabled equals true. Okay, so we first of all calculate our interpolator by adding on to it time.delta time multiplied by our interpolator speed, which remember is 1 over decay rate. And then we use that as the t-value to lerp between the source radius and the target radius. And of course you're not really going to see how this works until we create the setter functions in a minute, which set the source and target radius. But let's just assume these are two different radius values for now. We interpolate between those, and then after we've done the interpolation, we measure the size of the collider radius. Oops, I've said if collider is smaller than math epsilon, that should be collider.radius is smaller than math epsilon, obviously. And if it is, in other words, if the radius is pretty much 0, then turn off the collider completely. Otherwise, in all other situations where it's larger than 0, enable the collider again. Okay, let's work on those setter functions now. Actually, I probably need one setter function. So this is going to be a void return type. I'm going to have to make it public though, aren't I? Because this is something that is going to be called by other scripts on other objects, such as our character manager. So it's got a void return type. I will call it set radius. It simply takes a float, which is the new radius. And actually I think I'm going to take a second parameter of type bool, which by default will be false, but if we set it to true, it will cancel out the whole decay thing and will instantly snap to the radius we specify, just in case we definitely want to have that override behavior. So I will call this instant resize, like so. Okay, so whenever we set a new radius, whatever the current radius is has to become the source radius, our new radius has to become the target radius, and we have to reset our interpolator clock back to 0. So we will say, actually first of all we have to check that we have a valid collider. If we haven't, then we can't even fetch the collider's radius, so that's no good. We'll just return from the function and it will be a no op. Otherwise we will say source radius equals collider.radius, target radius equals the new radius that we just passed into this function, and we will set interpolator back to 0 so that the next time fixed update is called, we are now interpolating from 0 between our source radius and our target radius. However, there is one small matter here, which is we said we have this second parameter called instant resize, and when this is set to true, which by the way it will be set to false by default, but when it's set to true, we're not going to perform this interpolation, and we wish the radius to instantly change size. So what we can do is say source radius equals, and then we'll simply say if instant resize, then also set the source radius to new radius, otherwise set it to our collider's current radius. So what we're basically saying is if instant resize is false, source radius is going to be the collider's current radius, and we're going to interpolate between that and the new radius up here in our fixed update function. But where instant resize is set to true, we're actually going to set source radius and target radius to new radius. Then essentially we're just interpolating between two values that are exactly the same, which is going to set our collider's radius to the new radius that we've passed in. So we've almost got this right, but there was one other thing that we said that we need to do, which is we said we only want this interpolation to take place if the radius that we specify is smaller than the current collider's radius. So in the case where we wish to make the radius bigger, we want that to be instant, just like imagine if the player has jumped off a ledge and has hit the ground. We immediately want to resize. But in the case where we've had a big range and now we're just walking again, well then we want that radius to shrink down to the smaller walking radius over a small period of time. So we also want to do something similar here, but we wish to have something else there as well. We want to say if instant resize is true, or if new radius is larger than our collider's current radius, well then we're also going to use the new radius. So that seems to be pretty much done. Okay, so we need to test this now before we've really implemented our character manager, because it's going to be our character manager that's going to talk to the set radius function. But for now what I'm going to do is I'm going to put an update function in there that's just going to poll, let's say, the R key. And what I'll do is every update, this function will simply call set radius, and let's say sets it to 2. But when we press the R key, it will set that radius to 15. So what we should see is when we're just walking around, we've got a radius of 2, but the minute I press the R key, it should leap up to 15 and then should go back down to 2 over whatever we set the decay rate to. So I will say set radius 2. We can think of this as being the standard walking radius, okay, for this test. But I'll also say if input.get key down keycode.r, I'm just doing R for radius, that's the only reason I chose that key for now. Well then we will set radius to 15. Okay, remember this is just a temporary function, we're going to get rid of this in a moment. This is just like how I like to test things, so let's see how many errors I've got. I'm sure I've got dozens of them. I've got one at the moment. Oh, there you go. Left an F off there. Save that off. Go back again. See if I've caught them all. Well, it looks like I have. In fact, what I'm going to do for now is I'm going to turn off Zombie Jill in the hierarchy, alright? I don't want Zombie Jill coming and attacking me, or any of my zombies for that matter, while I'm just testing this. And I don't want the game view to maximize because I want to look in the scene view and see what's actually happening. Okay, what I'm going to do is I'm going to put the decay rate up to something like 10 seconds, so we get to see the sphere shrink very slowly back to this size here, or the size that I set it to. So decay rate of 10 seconds. Let's press play now, see what happens. Nothing's happening when I press the R key. Oh, and that's because I've spelled update up 8. There you go, so my key press was never being processed. Okay, so when I press play now, we should see the update function being called, and we should see this sphere instantly resized to the size of 2. That's the size of 2 there. Okay guys, are you ready for me to press the R key and see if this works? Look at that. It is working perfectly, and we can see our sphere shrinking. I mean, obviously we wouldn't use a decay rate anywhere near that size. We want something probably like, I don't know, 1 second is ample. Remember, the whole point of this decay rate really is just to make sure that it stays around long enough such that it doesn't skip the odd frame and not get picked up by zombies or the physics system. So that is more than enough, just a 1 second decay rate like that. And there you go. And even if we press it and it's in the middle of interpolating, it will always snap back to the beginning of the interpolation. Okay, so let's get rid of that update function now. It was just used for testing, and the test is complete, and it all worked absolutely fine. So what we're going to do now then is we're going to go into our character manager, and our character manager is going to store a reference to this AI sound emitter and is going to use that set radius function to set the radius of our sphere based on the current state that our FPS controller is in. So if it's running, it'll set a big radius. If it's walking, it will set a small one. If it's just landed on the ground, it will set a really big one. And we'll create some variables that can be exposed in the inspector of our character manager so we can set these things up as well. So let's open up the character manager now in MonoDevelop. Okay, so here we are in our character manager script, which at the moment is a pretty simple script, but we're going to be adding to this lots and lots over the coming videos. At the moment, it really just has two functions of note. The first is the take damage function, which is called whenever the zombie hits the player and the player needs to take damage, and it's here that we adjust the player's health and that we also communicate with our camera blood effect to make that blood come on the screen. And we also have the do damage function, which is essentially the reverse. It's what happens when we wish to attack a zombie that's in our crosshair. And just to remind ourselves, it casts a ray, and if it hits something, then it calls that zombie state's machine take damage function to apply some damage to the zombie. Other than that, we just have an update function. And in the update function, all we're doing at the moment is just testing to see whether the left mouse button has been pressed. And if it is, we call the do damage function to potentially do some damage to a zombie if we have a zombie in our crosshair. And now what we need to add is a new variable. It's going to be a serialized field again, so it shows up in the inspector. It's also going to be private, and it's going to be of type AI sound emitter. And that's so that we can hook up that sound emitter script that we've just added to our sphere trigger to this script, so that the character manager can communicate and set the radius of our sound emitter trigger when the movement status of our FPS controller changes. So I will call this simply sound emitter, and I'll set it to null because we're going to need to hook this up. So I'm now going to go back to the editor and make that connection before I forget. So if I select our FPS controller rig and make sure that you've got the character manager unfolded in the inspector, you can now see at the bottom of our character manager we have that sound emitter slot, which currently has nothing assigned. It's actually waiting for an object of type AI sound emitter to be assigned, which we know we have on our sound emitter game object. So let's drag over our sound emitter game object, and that's one of the really cool things about Unity, is that although we dragged over a game object, it knew the component that we were looking for, instantly knew it was the AI sound emitter script that we wished to make a reference to. Okay, so now that our character manager can talk to our AI sound emitter and can call its set radius function, we now need to do that logic. So how do we know when to change the radius of our sound emitter? Well, it's actually pretty easy because our character manager also maintains a reference to the FPS controller. And our FPS controller script, if you will recall, does actually keep track of our current movement status. If I scroll down here, you can see we even have a public property called movement status, and it's one of the player move status enumeration, which can either be not moving, crouching, walking, running, not grounded, and landing. So all we need to do is read this status back from our FPS controller within our character manager. And if we're landing, well, then it means that we've just landed on the ground, so we will make it a really big radius for our sound emitter. If it's running, then we'll also make it not quite as big as the landing, but bigger than the walking. And if it's anything else, either walking, crouching, not moving, or not grounded, which basically means we're falling through the air, then we'll probably just set the radius of the emitter down to 0. But you'll have total control over that via inspector variables that we're going to add to our character manager. So I'm going to make these serialized fields as well. They're going to be floats. I will call the first one walk radius, and I'll set that to 0 by default. I'll create another one called run radius, and I'll set that to something like 7, and I'll call the next one landing radius. In other words, when we've just hit the floor after jumping, and I'll set that to something like 12. Once again, these are all inspector variables, so we can change them all within the editor. Okay, and we'll save that off, and now we will scroll down in our character manager script to the update function, which is where we're now going to do all of this processing. And I better just make sure that I do have a valid reference to an FPS controller, because I need to talk to that script to get the movement status. So the first thing we're going to do in this function is we're going to create a new local variable that I'm going to call new radius, and by default we're just going to set that to our walk radius. Okay, we're going to assume for this test that we are walking. And then what we're going to do is we're going to do a switch statement that is going to switch the FPS controller's movement status. And really the only ones we're interested in are running or landing. In all other cases we are going to assume the walk radius is the audio footprint of our character. Okay. So the first test case will be when the player movement status is landing, when we just landed on the ground, in which case what we will do is we will adjust the new radius to whatever is the maximum between the current value of new radius and what our landing radius property is, like so. And then I'll do break, and I'm going to talk to you a little bit in a minute about why I'm using this max value here. And then I'm going to say case player move status is not landing but instead is running, and that's pretty much all we care about at the moment, landing or running, because in any other case we're going to assume that the radius will just be set to the walk radius, which in my game will actually be a radius of 0. And once again, if we are running, then we're going to set the new radius to mathf.max what the current value of new radius is compared to what the run radius property is that we've set via the inspector. So let me just step through what's happening here. Assuming we have a valid FPS controller, and in fact I should probably just check that we also have a valid reference to an AI sound emitter, then what we do is we start off by creating a new local variable called new radius, which we set to the walk radius, which is like our fallback radius. Then what we do is say if we're landing, then we're going to set it to our landing radius. If we're running, we're going to set the new radius to our running radius. But notice, rather than just do that assignment, we're doing this mathf max comparison to make sure that we only assign the landing radius or the run radius if those radii are larger than what we've currently set new radius to, which given the current code should always be the case, right? Because you're always going to want our walk radius to be less than our landing and run radius. However, the reason I've put this in place now is because in a moment I'm going to add a little bit of code up here which is also going to take our health into account and in a way simulate our player giving off the smell of blood when he's got damaged. So we're not going to do that just yet, but that's why I've put this mathf max comparison on both these lines, because it may be that if we're really damaged up here, we're going to assign it a value based on our health rather than the walk radius, and if we're really damaged, that value that we assign it may actually be larger than the landing or running radius. Okay, so outside the switch statement we can now take our new radius value, whatever it is, and send it into our sound emitter's set radius function. And in fact that's actually just reminded me that because we're essentially going to be calling the set radius function each frame, even if the status of the character hasn't changed, what we should probably do is go back to our AI sound emitter class, and in that set radius function we should also make it a no-op if we're setting the same radius that is already the target of this emitter, because although setting the radius to what it is already won't have any effect on the size of the collider, what it will keep doing is resetting this interpolator back to 0 again, which is not what we want. So where we say if not collider return, we'll also say if not collider, or if the new radius that we've passed in equals what the target radius has already been set to, what we're already interpolating towards, then we will return. Okay, let's see the errors here. No errors. Very surprising. If we look at our character manager in the inspector, we can now see we have the walk radius, the run radius, and the land radius. And I've got my zombie turned off at the moment, haven't I? Yeah. Okay, so let's press play and let's see if any of this works. Let me make sure I put the scene view in perspective and also zoom out a little bit so we can see what's happening. Okay, so there's that initial resize of the collider because we actually start off in the air here. So that was as we would expect. As we walk around at the moment, we can see we have absolutely no sphere around our player because we have a 0 radius for the walk. Let's see what happens if I hold shift and run. Hey, look, I've now got a louder footprint, and you can see that it slowly goes back down to 0 once I start walking again. It's not dead instant. 7 looks a pretty big radius. I'll leave it, no, I'm going to set it to 5, I think. And I'm going to set the landing radius down to 10. Okay, let's try that now. Okay, so here I am walking, here I am running. So you can see if I was to run up behind a zombie, it would probably, before I got to the zombie, detect that I was coming. And then I'm going to jump. And you can see when I jump, I create an even bigger sphere for a short period of time. So actually, I've changed my mind. I am going to put the run radius back to 7 and the landing radius back to 12. Then what I'm going to do is I'm going to turn on Zombie Jill. And at the moment, Zombie Jill is going to have a little bit of a freak out when it starts because I'm landing on the ground. So she's going to hear me instantly. Oh, actually, that's cool. It didn't do it that time, or did it? Yeah, it did. She's seeking for me already. Okay, let me get out of Zombie Jill's way, because what happened is she heard my initial landing on the ground, and as a result, she started to come looking for me. So we can see it really does work a little bit too well here. Okay, so wait until Zombie Jill's going about her business. So there you go. There you can see she's walking back now. And what I'm going to do is I'm going to creep around. Now, normally I'd be able to creep right round up on her without her knowing I'm there. You can see if I start running, she instantly stopped and is now coming towards me. And likewise, if I run away from her, which is quite hard to do actually, because while I'm running, I've got that massive emitter. So what I need to do is hide somewhere now. Right, where is Zombie Jill? There you go. I've left her on the other side of the bus. So what Zombie Jill should do in a minute is she should start walking towards her waypoint, okay, which is in that first room. So I'm going to go in the second room and I'm just going to show you how fatal jumping can be, because the zombie will hear the noise even if it's in a different room over the other side of a wall. So are you ready to see me jump? There you go. I've jumped a big emission. The zombie has stopped in its tracks and it said, what is that noise? I think that was coming from behind this wall. Will she come seeking for me? Actually, it looks like she's given up seeking for me there. But if I jump again, there you go, she's coming for me. And she's actually going to track that sound source right to the source. Okay, so that definitely seems to work. That's pretty cool. But we can go a step cooler. Remember I said at the end of the last lesson that what we would like to do is give the impression that zombies can smell our blood as we get more damaged. Well, our character manager already has a health property. So what we can do is we can just use the declining health property to set a minimum range for our sound emitter. Now, this isn't really like a true smell property for the zombie because it's piggybacking off the back of the sound system. So, for example, if we set the zombie's hearing capabilities down to 0 so that we've got a deaf zombie, well, then we've also got a zombie that can't smell the blood. But I think it's a pretty small price to pay because it saves us having to implement an entire smell system, which is just over the top. All we really want to do is give the impression that in most cases, if we're pretty bloody and we're pretty damaged, even if we're walking past a zombie and the zombie was, let's say, feeding on the ground, the zombie's going to stop what it's doing, start seeking left and right, and from the player's perspective, we're going to say, hey, that wasn't a noise, that's the zombie smelling us being close to it. So what we'll do is inside our character manager's update function, where we assign initially the walk radius as the default value to our new radius, we're going to do the whole mathf max thing here by saying new radius equals mathf.max, and we'll choose whatever is the greatest between the walk radius and 100 minus our current health. So obviously if we've got health of 100, that's just going to equate to 0 and the walk radius will be larger or the same, and new radius will be 0. But whenever our health is less than 100, then that's going to generate a value that is going to be the new default radius for even when we're walking. 100 minus health would create far too big spheres. I'm going to divide that by, let's say, 6. I think I tested 6 and that worked pretty well. So for example, if we were really, really damaged, let's say we had only 10% health, but then 100 minus 10 would be 90, and 90 divided by 6 would actually create a massive whopping sphere of 15. Actually, that might be too high. Well, yeah, but 10%, that's a very low amount of health. In the case where we've got, say, 50% health left, which is probably the amount will be damaged most of the time, well, then that's going to be 50 over 6. Yeah, which would give us like an 8-meter radius where zombies could smell us. So, in fact, I should probably make this 6 an inspector assigned variable, shouldn't I? So you can tweak with it in the editor and set the blood range yourself. This is another private float. I'll set mine to 6 by default anyway, and I'm going to call this blood radius scale, like so. Then if we go back down to our update function, we're going to swap out that 6 for our blood radius scale property, like so. So let's see if this works. I'm going to turn off Zombie Jill a minute so she doesn't get on my nerves. And I'm going to select my FPS controller rig. Now, as you can see, at the moment, we don't make any kind of audio footprint when we're walking, only when we're running or when we're jumping. But let's see what happens now if we start to reduce our health. Hey, look at that. So once we've got a health of 50, we are actually giving out we're giving out quite a big smell, aren't we? So maybe we should change the blood radius to about 7. So I'm going to set blood radius scale to 7. And once again, you can see that if we end up with like very small amount of health, like 10%, then pretty much every zombie in the level is going to smell us. So we need to really get a med kit fast. When we're only, let's say, quarter damaged, 75% healthy or 25% damaged, you can see that really only zombies that we get close to are going to smell us. So as with when we're running, this is going to cause a problem if you're trying to sneak up behind a zombie and you don't want it to know it's coming for a surprise attack, maybe a crowbar across the back of the head. As you start to approach the zombie from behind, it's going to smell you and it's going to try and turn around and attack you. So I'm going to round up this lesson here. We've added sound and smell to our zombies using a sound emitter on our FPS controller rig. And in the next lesson, we're actually going to round up our AI coverage. Now, we are going to have to come back much further down the road when we have our interactive environments working. And we are going to have to do a little bit of additional AI work just to make sure that our zombies can handle things like doors that open and close and things like that. But in the next lesson, we're really just going to have a nice light lesson showing how we can set up a couple of zombies using instances of the controller but change their motion fields so that they can all behave differently and have different animations. And it'd be surprising how many different looking zombies you can get out of the same controller just by tweaking the motion fields. And the AI Zombie State Machine inspector variables. So I'll see you next time, everybody, when we finish up phase 1 of this course and get moving on to more interesting stuff such as interactive environments.